All right, here we go. Ionization energy and electron affinity. Ionization energy of an element is the energy required to remove an electron from a gaseous atom. So it's important to recognize it's got to be gaseous. So gaseous sodium losing one electron to produce, this gaseous cation. Periodic trends of ionization energy vary with atomic radius and effective nuclear charge. As atoms get larger, ionization energy decreases, making it easier. So lower ionization energy means removal of electron is easier. Second ionization energies are always greater than the energy of the needed to remove the first ionization energy. So to apply that, if you look at Na gaseous to this, so this, i.e., let's just call it 10. That'll be your first ionization energy. Now to go from Na plus gaseous to Na2 plus gaseous plus an electron, your ionization energy would be something like, let's say, 700. So it's significantly, or it's always going to be larger. Removing of that second electron is always going to be require more energy than removing the first one. Here's your trend. First ionization energy increases starting from here up. Atomic radius decreases from here up. First ionization energy increases from here going to the right. Atomic radius decreases from here going to the right. So you see inverted trends there. As ionization energy increases, the atomic radius decreases as ionization, and yeah, there you go. That's it. Here's some examples of ionization energies, and just to show the magnitude of them. Sodium goes from 495 for the first ionization energy, kilojoules per mole is the units for this. Second ionization energy is 4562, and the third is 6910. So that ionization energy increases between the first and the second across the board. Electron affinity of an element is, well, it's basically the opposite. The electron affinity of an element is the energy change when an electron is added to a gaseous atom to form a gaseous anion. So negative electron affinities represent a decrease in energy when an electron is added to a gas phase atom. This is an exothermic process. Positive electron affinities reflect an endothermic process, and energy is required to add an electron to the gaseous atoms. Your electron affinities, well, they're a little bit different, but if you look at something like, they are significantly lower in the lower left-hand corner compared to the upper right-hand corner. I would say your biggest takeaway from this presentation is the trends, for specifically the trend of ionization energy. It's also important that you recognize that ionization energy, your first versus your second versus your third. Your first ionization energy is arguably going to be the lowest, the second is going to be higher than that, the third is going to be even higher than that. But I hope this is helpful, and you got this.